Hey everyone, welcome to the React Native workshop. My name is Adarsh, and I'll be walking you through some of the more fundamental aspects of React Native. So what is React Native? React Native is this React-based framework. React itself is a front-end framework that utilizes JavaScript code to create very robust web applications. The end goal of React Native is to build native Android and iOS applications in JavaScript using the React framework, HTML and CSS. So you can see here we have an iPhone and we have an Android. They're running through two different operating systems, but the same application, only using one singular code base. So all this is to say is the end goal of React Native is to produce seamless cross-platform support. So before we dive into what React Native really is, we have to talk a little bit about the core architecture. Since React Native is dependent on React and React itself is dependent on JavaScript, JavaScript actually plays a very key role in the development of our application. Therefore, we should really talk about the JavaScript runtime environment or how it works in the web browser. So JavaScript really is driving the React Native application. The JavaScript engine is how JavaScript code and by extension React code is powered. It uses a singularly main thread and uses things like memory over here, an event loop, which is critically important, and a job queue. These several aspects are important because it describes to us how different commands written in JavaScript are passed through a particular call stack or memory heap and fed through the job queue and eventually driven by the event loop. To further explain the architecture of React Native, we also talk a little bit more about the total architecture. So you can regard this aspect over here, the JavaScript thread, as something I've talked about previously. However, do note that there is the React Native JS library and the React component library, not necessarily library, but aspects of the thread that are new as a result of the introduction of React Native. The important aspect to really be clear here is the native or main thread, which has native modules implementation, native commands, and even a UI manager module. The point is to take all of our JavaScript code and somehow use this sort of bridge and thread to connect all components together in order to make an application that seems native, but really written in JavaScript.
Hello, my name is Sam, and I will be picking up from where Adarsh left off. So, at this point in the workshop, hopefully you have a pretty good understanding of what React Native is and why you might want to use it. So, now I'm going to go over some of the core concepts and components that you're going to run across in most, if not all, React Native applications. This is by no means an exhaustive list, but again, these are pretty common to all applications built with React Native. So, the first idea we're going to talk about is that of state. And so state basically is all the properties that describe any particular object at some given time. And so a real world example of this, if you want to think about it, is like an elevator, right? An elevator state can be it's on floor 1, it's on floor 2, it's on floor 3, or etc. It's going up, it's going down, it's at a standstill. Its doors are open, its doors are closed. All these things are aspects of the elevator state. And so state is handled in React Native. And so for a more like React Native relevant example, think about like whether or not a particular menu is open, whether or not a window is being displayed, whether or not your user is logged in. So all of these things are parts of things that are aspects of an app's state. And so for React Native, state is dealt with in two ways. You have your classes and you have hooks. So classes is the older way of doing things. Hooks is newer. Hooks does resolve some of the issues that were prevalent in classes. So JavaScript classes had their own little quirks that hooks came around and solved. But classes is arguably the more intuitive way of going about understanding React and React Native, especially if you are a beginner. And so for this workshop and for most of the tutorials that you're going to find out there, classes is going to be the go-to. And once you have a grasp on classes, it's not too much of a haul to then go and do the same thing and do the same kind of work in hooks. So moving on, props, which is short for properties, is basically all the things that you pass into a component that directly impacts the output of that component. So it's similar to like the arguments of a function. If you have like a function that adds x and y and returns a sum, then x and y in this case would be similar to your props for that function. And then we have style. So style is basically, so React at the end of the day is a front-end framework. And so React Native, which is built on React, is going to be very heavily focused on the presentation of your app. And so style is, we want to be able to influence, we want to be able to control how our app looks, how each of our components look. We want to be able to have an easy way of doing that. So Flex, which is short for Flexbox, and this is derivative on the word flexible, is one of the many ways to style different components in if you're just working with front-end web development. For React Native in particular, Flex is the standard way of going about things. And so I'm not going to go too in depth into that for now. We're going to have a concrete example at the end of this, and so just kind of keep that in the back of your head. So now we have components. So these are going to be the actual pieces of code that are going to be in your React Native app. So we have your view, and if you've done any web development before, front-end web development, this is analogous to your div container. So view is basically just your most general container. You can put anything inside, and it comes with no really like built-in functionality, and so it's very general. Then you have text, and so text is specialized to self-explanatory for displaying text. You put any text you want to display inside this kind of container. Image, same thing for images. Scroll view is pretty self-explanatory. It's like a view, but it comes with scrolling. And so you can imagine why scrolling would be important in a mobile application. Then we have text input, which is where your user can input their own text into the app. Moving on. So now let's ask why we want to use these open source cross-platform frameworks in the first place. So number one, reuse of code. With these frameworks, you don't have to reinvent the wheel every single time. A lot of the code is abstracted for you, and so it makes things development a lot quicker. Then we have community support for JavaScript. So this is more relevant for React Native in particular. And so JavaScript being one of the most popular programming languages in the world, you do get all of the questions that people have asked over the years and all the answers that they've gotten. And you have all this great documentation. And so there's a lot of good support for JavaScript, which is the building block of React and in turn React Native. Minimal learning curve. So React Native, and this kind of deals with the next 2 points as well, low cost of development and really convenient. React Native is intuitively laid out. It's pretty easy to understand how things flow, and the code is, again, it's well laid out. It's well documented. It's easy to understand. So these are kind of all the reasons why you might want to use these platforms, in particular React Native. So now, why do we want to use React Native? Or I guess move it back a step, which one of these open source platforms is the best? So there are several out there. React Native, again, of course, is the one we're focusing on. Alternatives include NativeScript, Flutter, Xamarin, and Ionic. So all of these have their own pros and cons. There are different people who will prefer different frameworks. React Native is the most popular one out there right now. It's also one of the more well-supported ones. It has really good community backing behind it. And it is also very performant. So it does well in terms of what its job is, which is to run non-native code as if it was native. So yeah, here is kind of a chart that compares all of it. This workshop will be, I believe, available for you to view later. And so don't feel like you need to write this down or memorize all of this. This chart can also be found online. So basically, again, React Native is very close to native in terms of performance. And so the difference between writing an app in React Native versus if you were to write it in just Swift or Java or Kotlin, difference there is very minimal in terms of performance. And again, the community is very strong for this, so you're going to have a lot of support with using this framework in particular. Okay, so there are downsides to using these frameworks. Number one is because you're getting this perk of convenience and reusability, and the fact that you don't need to write different code bases for different platforms, you are going to get a lack. You are going to take hits in performance and speed, right? So it's kind of a trade-off there. You're going to gain convenience, and you're going to lose some performance. There is a little bit of a learning curve, especially if you haven't done any work with React or front-end web development before. However, this is kind of a smaller con because there really is kind of a learning curve to anything new that you're learning, any new technology, any new programming language. But this is basically saying that even though the learning curve is minimal for React Native, it is still there. When you're writing in React Native, you are dealing with the fragility of JavaScript, so your security for your app might not be as robust as if you were to write in one of the native languages for your particular platform. And then finally, you might run into the issue of having insufficient components. And so React Native provides components for you that you can customize, but they are basically, if you want to think about it as like pre-built like chunks of Lego bricks, right? So if you were to write in a native language, you might have the individual Lego bricks. But with a framework like React Native, they are pre-built for you. It's easier, it's more convenient, it's quicker, but you lose that fine-tuned control that you might get with a native language.
Thanks, Sam. Hi guys, my name is Hucky and I'll be picking it up from here. So now let's go over a few examples of the applications that are using React Native today. As you can see on the screen, there are some apps that you might even use on a daily basis. For example, there's Facebook, Instagram, Skype, or Discord, and those are the ones that you might be familiar with, but there's also companies like Uber, Walmart, Tesla, and Oculus that also uses React Native frameworks for their applications. This shows that React Native can be used for so many different types of applications, which is really perfect for you and your team to use for future projects. Now we're going to do a quick introduction and walkthrough of a simple React Native application as an example. If you go to this link right here, which is snack.expo.io/SEOKHEEHONG/to-do/list, you'll be able to go to a Snap project called ToDoList. So let's go ahead and do that really quick right now. And so now you'll be able to see this to-do list Snap project. So Snack is an online code editor for React Native, and it allows you to test code without having to install React Native. Everything is all on one page, which makes it easier for you to quickly test or share your React Native code. So as you can see on the left, we're on this file called app.js, and on the right, you'll be able to see one of the main parts of Snack, which is the emulator. So you can download the Expo app, and you can either run the simulator on your phone, or you can just use the online emulators for iOS or Android devices, or even the web app right here. So let's go ahead and go through what the to-do list app does. And so we'll go on the Android screen, tap to play. You'll see a quick loading screen with the Expo logo. All right, so we're in the main screen right now. On the bottom, you'll be able to see a placeholder that says Add Tasks. So as a to-do list, let's see, what do I want to do? Let me go ahead and click it. You'll see a keyboard popping up. I'll just type on my keyboard. So let's say I want to drink 3 glasses of water and press Enter. And there you go. I have my first task on my task list. And let's add a couple more. So let's go to bed by, say 11 p.m. because you're really tired. And another task, eat ice cream. All right, so you have all your tasks, and what you just did is you added 3 tasks, right? But say you want to delete a task. Well, from this UI interface, it's really easy to see that to delete a task, you would just simply press on this X button. So say I don't want to go to bed by 11 p.m., so I'll just simply take that out. And those are the main components of this app that we'll be going through today. And let's dive straight into the code now. All right, so on the left, you'll be able to see all the color coordination going on with the React code. And you'll see all these comments are just documentation to help you kind of guide through what these code and components all mean. So let's start. On the very top, you'll be able to see all the import statements. So the first line is importing from React, and we're importing components in React. And the next few lines are importing components from React Native. So some UI features such as buttons, text inputs, or keyboards, or the platform, those will all be imported from React Native. So let's go straight into the code now. So the main class that we'll be working with is called the ToDoList class. And so let's start by looking at the state. Our state will have an array of tasks and a string called a text. So just keep that in the back of your mind. And this kind of makes sense because we'll have a task list, and inside that task list, we'll have the text in it. And let's move on to the next portion, which is the change text handler. So this function deals with what the user has entered. So if you really think about what's the first thing that the user is going to do, well, they're going to type something in the text box. And we have to kind of notice that change in the text box. So what we'll do is we'll use the setState function to schedule an update to the component. So this is kind of letting them know that a change is going to be made. Now, there's 2 main functions that we'll have to define in the ToDoList app, which is the add task function and the delete task function. So the add task, like it sounds like, it's going to be a function defined to add tasks to your task list. So when the add task function is called, you'll be checking whether or not the text box is empty. So if the user types something in, then from the previous state, which is before the user types something in, we're going to concatenate that new string. So whatever the user types in that text box, it'll add that string into the tasks array. So that's what's happening right now. And then of course, after you add that, you want to save that state. So, and that's just going to save that array, and that's the add task. And similarly, but not too similarly, with the delete task. So again, the delete task is a function defined to delete your tasks. And so when the delete task is called, you're going to splice the tasks array. And what splicing means is that it's going to remove the selected element from the array. And of course, you're going to return what is left. And you're going to save that state of the array, which is after you splice it, so after you deleted that task. So we just went through 2 of the main methods, the add task and the delete task. You'll be seeing these functions in action in a little bit. So just keep that in the back of your head too. And let's keep on moving on. All right, so now we're going to be looking at this component did mount function. So this handles the event where the component is mounted. And in this case, the component is going to be the keyboard. So the add listener function kind of like detects whether or not the keyboard is being in use. So if Android is true, so if you do have an Android phone and the keyboard is in use, then the keyboard will show up, basically. And when the keyboard shows up, we want to adjust the padding just a little bit. So that's what this function, this line of code is doing right here. It's just adding that extra padding to compensate for that keyboard popping up. And then we also have another listener for when the keyboard needs to hide. So when you're not using your keyboard, it should hide, and the padding will go back to normal, to its normal state. And if we remember, at the very top before the ToDoList class, the view padding was actually initialized to be 10. So it'll just go back to that state. Let's go back. And that's the component did mount function. Now, for the last method, let's go over the render function. So the render function basically loads the code to the platform. So some of the main things that's happening here is that, well, a lot of this is the HTML code. As you can see, there's the button, like the X button, that triggers the delete task function. So we define the delete task function above, and let's look for the add add task function, which is right there. So on submit editing, oh, let's start from, all right, so let's start with a text input. So this part, so this text input is over here on the right. You'll be able to see it on the bottom. So this part is where the user's input is going to add the task. So on change text, this is going to detect whenever the text changes, it's going to call the change text handler function. And whenever you're submitting that text change, so that's when you submit enter, then it'll call the add task function. So you can see the functions that we defined above being in use right here. And just a quick note, the placeholder add tasks, this is really easy to find. As you can see on the emulator, it's on the bottom. That's where you know where you're supposed to type. You're supposed to click right there and add your task. And that's the render function. So the render function, again, loads the code to the platform. It kind of brings all of that together and calls all the functions that you need. All right, so now let's go over the tasks really quick. So the first method in tasks would be the convert to array of object. So this is kind of what it sounds like. So this method basically converts the tasks to an array of objects, and this can compare to the convert to string with separators method, which converts the tasks to a string of separators. Another method you can see is the all with the callback parameter, and this basically calls the async storage to fetch all the items that we stored there. So async storage is a key value storage system that is global to the app, and the get item function fetches the data for us. So we're getting all of those items. And of course, that can compare to the save method, which does a similar thing where we call to the async storage, but this time we're setting the items. We're calling the set item function to store the data back up there, which makes sense because when you save something, you're storing the data. When you're calling the get item function, you're getting all of those items in the data. So now let's move on to kind of like the style sheets. So this is really similar to CSS for those who know a little bit of web development. And the style sheet basically dictates the colors, layouts, and the fonts. And each of the elements on the app are labeled with an ID. For example, the container is an ID, and the styling components following it will be applied to all the elements with that ID. So for example, all of the container IDs, so if I have a container named A, a container named B, then A and B will all have this same styling components. So the way that you would write this is just as if you would be writing in CSS, but with a little bit of syntax changes such as camel casing here, instead of your usual dashes, and they use a lot more quotations, in which in CSS you wouldn't use those quotations. And down here, I just have another example. So every type of list item will have a padding of 2 on top, a padding of 2 on bottom, and a font size of 18. So, and the last part of this app is the app registry. So app registry is the JavaScript entry point to run the React Native apps. So this kind of really starts everything. And yeah, so that's the ToDoList application that we went over. And now let's go back to the presentation. Here's the link to the GitHub repository for the actual React Native code. So let's go ahead and click the link, and that would be github.com/bandyhacks/React Native workshop. So here you can see that there are actually many more files in a React Native project than you might expect. So the app.js file from the stack that we were working on can be found under app, and it's renamed into index.js. And you can see that all the code, so this is the exact same thing that you saw in the snack, all the code is being implemented here. Let's go back to the main repository. So compared to the snack, you can see that there are separate Android and iOS files in this repository. You can see that the Android files are going to be right here, and the iOS files are going to be right here. And there are more React Native-like code, such as Java files or Objective-C files. So for example, if we go into the Android folder, let's go into app, let's go to their main, and you'll see that the main activity and the main application are in Java files. So in Stack, you only work with HTML, CSS, and React, which is again web-based, but this repository, or when you work locally for React Native projects, you'll be having the full-fledged project in your hands. Okay, so That's the GitHub repository. And yeah, so that's React Native. As a quick wrap up, so first, React Native is a great alternative to native-based frameworks. Second, there are many different uses for React Native, which means that it can do quite a few things. So take that into consideration when you figure out what you and your team need or want when you're making an application, or if you end up using React Native. And overall, just do a research. Go out there and find what other things that React Native can do for you. Whether that be looking up examples, looking up more open source repositories, creating your own projects, or just getting creative. So that's it, guys. Good luck on your React Native journey. Make sure to visit our other workshops if you can, but other than that, thanks for tuning into our React Native workshop brought to you by the Bandy Hacks content team.